In our next section, we're going to begin discussing automation tool sets. We're going to take a brief moment of time to discuss three of the more popular automation tool sets out there today, some available freeware as well as for pay for consume. So a lot of these have a freemium model, and then they also, of course, have an enterprise model with full support and a lot more enhanced features out of the box. And so namely, these on the agenda are going to be Puppet, Chef, and then Ansible as well. That's not to say that there aren't certainly a number of others, SaltStack, CF Engine, things like that, but these are predominantly the more commonly used, so we'll talk about these for a little bit. So let's first discuss Puppet. Puppet is largely a network device orchestration support, or has a lot of network device orchestration support. It does certainly work very well with traditional hosts and VMs as well, but it allows us to integrate network devices with various means of configuration management and various orchestration stacks. So when we take a look at an overview of Puppet, we see that we have this centralized management server called the Puppet Master. And here we have a graphical interface as well as a command line. We have various workflows that can be created and instantiated, various levels of role-based access control for admin and security and reporting. And we have these distributed agents that go out on our compute nodes. So on our VMs, we would have installed a Puppet agent, or possibly even Cisco routers and switches that support this, and we'll discuss how the Nexus 9000 does, of course. We would have this agent, and the Puppet Master essentially directs the agent on how to comply with the Puppet files that essentially have the configuration that should, or let's say minimum versions that should be patched or installed if not there. And these agents go out, they reach out to the Puppet Master server, and they find out what they need to do to comply, and then the agent takes care of bringing that host, that VM, that router, that switch into compliance in relation to what needs to be installed, or also how things should be configured. And we also have some third-party integration for monitoring or pre-built solutions like cloud-based repositories like Puppet Forge. So taking a look at some, just kind of some numbers around Puppet from an open source perspective, like I said, the free version as well as the enterprise pay-for version. So we do have quite a large environment around Puppet for nurturing innovation. Approximately 8,000 members belong to this group. There are certainly incorporating the latest technologies and allowing for rapid release cycles of new projects and new features. Almost 1,000 changes per week, so a lot of effort and rapid change going into this open source. When we take a look at the enterprise environment, we have this very feature-rich IT automation for business-critical applications. This is mainly for commercial functionality. It is a single integrated solution. There is a graphical user interface complete with installer and upgrader, and of course anything that you're running there has gone through quality assurance and testing and been security hardened to make sure that it's ready for the enterprise, as well as gone through a lot of performance tuning, regular support and maintenance, guarantees on the API that they're going to work and support around those, and even corporate training and services. So taking a look at what Puppet does. So here we see step one. We see that the first thing is to define. And Puppet does use a declarative language where we essentially define a graph of relationships between various resources within the different modules that are reusable in Puppet. And these modules essentially define your infrastructure in its desired state, whether compute or really anything that runs the Puppet agent. Could be storage, certainly our routers and switches that support this. So then step two, we go to a simulate stage. And with this resource graph, Puppet is a little bit unique in its ability to simulate deployments and enabling us to test what changes would essentially what they would produce without actually disrupting our live production infrastructure. Then we go on to step 3 at the bottom, where we have the enforcement stage, where Puppet compares the system out at the agent, where the agent's running, or obviously multiple hundreds or thousands of agents running on our various VMs and switches, and essentially compares that against what the Puppet master has stated in the definition, in the declarative policy. And then it enforces it. So it brings the state of the VM or the host running the agent up to compliance with the declarative Puppet master server. And then finally, of course, nothing would be complete without reporting, so everything is reported back to the Puppet master. The Puppet dashboard reports and tracks relationships between all the components and their various changes, allowing us to keep up to date with security and compliance mandates. And with the open northbound REST API, we can integrate Puppet with various third-party monitoring tools, as we mentioned before. So again, we've already talked about some of this terminology, but the various pieces, we have our Puppet master, which is essentially the central controller software. It orchestrates the configuration deployment for all of the agents, and these are expressed as what is called a manifest. The agent is the software which runs on the VM or the switch or the router, and it talks to a single Puppet master to obtain and grab its configuration, the desired configuration, and understand what Puppet resources should be involved. So it uses this Puppet resource provider to carry out the various tasks that bring it up to compliance or desired state. Now the Puppet resources, this term is used for grouping together different objects, managed objects or attributes, and one or possibly more of the corresponding implementations of the tasks required for the management. So there's really 2 layers of a resource. First is the resource type and the resource provider. So the resource type defines what the managed objects are, and the resource provider defines how these should be implemented in terms of management tasks on the various objects. So breaking down the terminology a little more, we talked about this idea of the manifest, which is essentially the desired state or configuration. So this is a collection of various configuration settings in terms of the resource type instances that we just talked about. And this is often referred to in the Puppet world as code. So manifests are commonly organized into sections that are mostly generic, but we can have very specific types of sections for very specific types of nodes using conditional logic, so using if-else type logic. So if something is some way, then do this, otherwise do this. So we also have a Puppet catalog, which is essentially a compiled form of the manifest or the code for a specific node. And here all the variables have values, and the conditional logic has been executed to result in what we call a concrete resource instance value. So then we also have something called factor, which is basically software that discovers what the runtime state is on a various agent node. And then factor facts, which are, it's always fun to say, factor facts, but this is basically what is the runtime state for a Puppet agent node. So these values can be expressed as strings, integers, values, and arrays. And these facts use variables in most of the Puppet context. So for instance, the Puppet master manifest, the resource type, and the resource provider. So here's an example of a workflow. So we see a node out on could be the network, could be a switch, could be more traditionally a VM. And essentially, the first step is for the node, the Puppet agent running on the node, to go out and gather facts. So the node basically sends the normalized data about itself to the Puppet master. And of course, it has to have a base configuration that the agent knows what master to contact, at least from an IP perspective, as well as, of course, SSL encryption information is gotten when we contact the Puppet master. So from there, the Puppet master uses the facts that it's received to compile a catalog that basically specifies how the node should be configured. So this is where the manifest is pushed down to the node. So then the node applies that, the agent applies that, and then the node, as a third step, reports back to the Puppet master, indicating its configuration is complete, or if there was a failure, what that failure was, why it could not complete its configuration. And this is, of course, going to be visible in the Puppet master dashboard. And then finally, it's going to report, and it could just keep it there on the dashboard, or it could send it through its open API to third-party tools. So again, taking a little bit more of a look, we have, for instance, here the Puppet master, and we have various hosts or VMs. For instance, Fedora Linux, we have HPAIX, we have a Debian-based Linux, and here on our Puppet master, we see various resource types, such as a file resource, a package or binary resource, a various service resource, or whatever resources we have defined. So then the agents essentially go through that four-step stage that we just talked about, and they get their desired state, or they send their facts, and then they get their manifest, their desired state or configuration essentially, and then they apply that. So here's just kind of a little bit of an example of the Puppet language. So here we see information in this format. We'll talk a little bit more about what this format is, as well as everything else as we go along. So I'll just leave this here for right now, but we'll talk a little bit more about this as we go along. So let's talk a little bit about Cisco NXOS Puppet integration. So essentially, how does Puppet work with Cisco Nexus switches? So again, we still have our Puppet master, but we also have the agent now running on our Cisco Nexus 9000 and 3000 series switches as or in a Linux container. And we'll talk a little bit more about this as we continue on, but we do have these Linux containers built into our NXOS operating system. And we're not talking about ACI mode, by the way. So we are talking about NXOS standalone mode. And of course, we've already defined that our Nexus series switches, specifically the 9000s, can either run either NXOS standalone or ACI mode software. In ACI mode, there is no config T, there is no show run. They all talk to the APIC controller through the OpFlex protocol, and they get their configuration that way. And all of our configuration is done via REST API, as we talked about earlier, or via the web interface, which ultimately calls the REST API. And that configures via OpFlex the NXOS switch, the Nexus 9K switch. However, when we're running in NXOS standalone mode, this is where we do have the ability to have this Puppet agent running alongside all the rest of our compute, storage, VM type nodes, and able to have a Puppet master apply configuration. So we essentially have this plug-in architecture now within our data center network. And the various switches and routers that support this, and of course our Nexus 9000 we've also already defined, but just for kind of rehashing and refreshment, we are essentially running Linux as the OS, not essentially, that is what's running. So NXOS is not the base operating system. In fact, Linux is the base operating system on the Nexus 9K, and then on top of that, as a sub-process, is NXOS. So this is true with ACI mode as well as NXOS standalone. So since this is Linux, essentially, we have the ability to run LXC or Linux containers. And this is where our Puppet agent runs and then interacts with the network operating system component as another process ID. So here's an example of a Puppet manifest for a Nexus 3K. And keep in mind the Nexus 3K and the Nexus 9K, they both run the exact same code, right? Nexus 3K, Nexus 9500, 9300s, every single Nexus 3 and 9000 series switch all have one software image for 9K standalone, for NXOS standalone. So here we see our node defined. We see some include information, notify, Cisco VLAN hostname being presented and essentially configured. So we'll talk a little bit more about this as we go along, but here's just a sample. So as we mentioned, this is packaged as a virtual service running in a Linux container as an OVA. The OVA registers these CLI extensions for configuration, show, exec, clear, and debug commands. And the OVA syslogs are linked to the NXOS syslog. So for instance, a show log on the Puppet Linux container, or the Linux container running the Puppet agent, I guess I should say, are going to effectively give us the same information as show logging would on NXOS. So for instance, if we wanted to have, let's say, 1PK set a VTY service, we could go in and configure this application called 1P, set service for VTY, do similar configuration with NTP server. And we can also go in and I guess I maybe should go back and say this is actually required. These are prerequisites. So we have to set this 1PK service set VTY, and we must have NTP synchronized. Otherwise, SSL is not going to, if we're too far off in drift from the Puppet master, the SSL certificate usage could have a lot of problems, especially multiple years off. But you always want to have NTP running in any network environment, especially a data center anyhow. That should probably go without saying, but it is critical when we're running with Puppet. We're dealing with any sort of certificates. So then we go into the Puppet configuration mode. We essentially say Puppet. We define who the Puppet master server is. Here we're doing it through DNS, or fully qualified domain name. Could be through IP as well. Specify the VRF, most likely the management VRF, but it could be a data VRF. Essentially, when the Puppet agent should run, how often it should go out and send its facts and collect its manifests and reconfigure, or try to apply configuration to maintain or achieve compliancy, and then activate it. And of course, if we are using FQDN, then we need to make sure we specify at least the name server, and preferably also our search domain or our base domain, especially if we don't. Actually, we really need to have this so that we ourselves have a fully qualified domain name as well. Make sure you also have reverse PTR pointer records set up in your DNS. So various Puppet run modes. We have either one-shot mode, no-op mode, or however you pronounce it, daemon or daemon mode. So one-shot mode is going to be essentially a single run of a Puppet agent to request the configuration and take action to achieve compliancy, put it in the desired state. No-op is going to be a single run of the Puppet agent to request configuration, but not to take action on the resources that are passed down in the manifest. And so this would be used in a scenario where the Puppet master user wants to validate or inspect the catalog being compiled for a node and understand essentially the delta, or what the difference is from the current state, but we don't actually want to make any changes. We essentially want to see what would happen and test this. And then daemon mode, where we have a reoccurring periodic update. We're going to go out, send our facts, request our manifest, and take the action to put the various resources into the desired state. So here's an example of a runtime report. So here we can see, for instance, that the Puppet master has gone out. It has achieved or downloaded various manifests and gone ahead and changed the VLAN, changed a particular state from running to stopped, and applied a description for various interfaces. So taking a look at some of the Puppet resources for Cisco. So a couple of use cases where this might be very useful. For instance, with an image or patching situation where we want to bring our Nexus 9Ks up to a standardized image. We have our repository, we have the Puppet or Chef master. In this case, we're talking about Puppet, of course. And we have various device plugins that we want to be installed. So we want these agents to go out and find their manifest, which is going to state the images and patches that are going to be applied. Another example would be, for instance, so we have new servers or new VMs that are being deployed on the network, and we need to apply not only, of course, they themselves, the VMs and hosts, need to have Puppet bring them up to a desired state or install an OS, patch them, install various components, bring up the network configuration. But we also need to have the switches at the top of rack provisioned to allow these new hosts, maybe on the individual ports, or maybe the VLANs they're going to be transmitting on don't even exist on the top of rack switches yet. So we would use this for top of rack configuration for every new device, whether hardware or virtual, that's being onboarded to the network. We can reduce the overall manual process, and essentially that Puppet Master is going to put the new server in the right VLAN or segment, apply ACLs, like I said, create ACLs, create VLANs, whatever needs. And then also things like various security policies, management, services, things that are just common across the network that we would do either at bring up at runtime or as things change. Maybe a DNS server or a syslog server changes or something like this. So we have a few different pages of the various Puppet resources types specific to Cisco. So for instance, we have on the left column, we have the feature, what the resource name is in Puppet, and then a description. So for instance, our Cisco device access is labeled as Cisco_device, and this allows for credentials, RBAC, user control, and accounting. We have our basic layer 2, layer 3 interface configuration. So Cisco_interface is the resource name, and this gives us the ability to apply general L2 and L3 configuration settings. Of course, VLAN for deploy and destroy of VLANs. Interface VLAN or SVI, so Cisco_interface_VLAN, deploy, destroy SVIs and SVI settings like IP address. Something that no one should ever run, so we should just skip it altogether. SNMP, so please don't ever run VTP, okay? If you had any question or said, why'd you say that? You haven't experienced a VTP failure where it will take down your entire network and reduce it to a flat VLAN 1. Don't ever run VTP. There are many other ways to do things, like Puppet or Chef deploying VLANs. Okay, so SNMP, obviously Simple Network Management Protocol, probably goes without saying, and we also have OSPF specific configuration. So a few additional resources. We have TACACS and AAA. These have actually become a lot more enhanced, or I should say exhaustive, since this first slide was published. And then just raw config CLI. So we actually can just simply configure using Cisco command config almost anything we want, but it's not necessarily as well formulated or well contained as some of the other things like AAA or like interface or SVI. So this is just kind of Wild West, and you can put in anything you want. So for instance, with the Cisco command config resource, this allows us, as I mentioned, to directly apply config via CLI. So allows command blocks with all of their sub modes. So as we drop down into lower hierarchical, as we do config T, that's obviously global config mode. Then we drop into an interface, and although Puppet has something for that, maybe we drop into router BGP. Then we drop into address family IPv4 unicast. Those sub modes is what we're talking about. And so these perform basic logic on the configuration commands. And essentially the intent of this resource is to cover the gaps and basically give us, like I said, support for anything else and provide all these real abstractions. So allows for full configurations, even if it's not a truly optimal abstraction. As I mentioned, it's not a proper container that's been defined. But again, these things will continue to evolve as this is relatively new, depending on when you're watching this. This Puppet support is relatively new for the Nexus 9000. So taking a look at the life cycle of the Puppet OVA, when we take a look at essentially how we're going to apply, step one is that we power up our switch, and it essentially has no startup config or default image. So at this point, POAP, or Power On Auto Provisioning, would reach out through DHCP, and we have to have, of course, a DHCP server. We're also going to have a TFTP server. And it's going to get its IP address, its gateway script server IP, and the script file name. At this point, we're going to grab from a TFTP server the script, which will execute locally on the NXOS switch. From there, we would have our Puppet OVA somewhere, and we can download this software image from wherever the script essentially tells it to pull from. Download running config, download the Puppet plugin OVA, and the activate Python script, which will activate Puppet. At this point, the router or switch would reload with the downloaded software, running the plugin activate Python. It's going to execute and install the actual Puppet OVA. And then once the plugin is activated, the Puppet agent running inside the container will establish a session with the predefined Puppet master and send its facts, retrieve its catalogs, retrieve its manifests, and apply configuration as we saw in the process earlier. Okay, so how are we going to do our initial install? First of all, the Puppet OVA is posted to CCO, or Cisco Connection Online. And of course, the customer is going to download this OVA to their file server. And then on the various nodes, POAP or NXOS hosted Python script would be used to reach out and grab via secure copy or SCP, grab that OVA and pull it down to the node. It's going to install and activate that virtual service, the Puppet agent, and then configure Puppet by the Puppet master, as we just talked about. So you do get this OVA from CCO, and you put it on your various TFTP or whatever server you're going to host this on, SCP preferably. So there are a few references we can take a look at. You're certainly free to just Google Puppet. You're going to find plenty of information out there. These are some that are particularly useful. Some general getting started information on, what is Puppet, basic hands-on tutorial along with a free VM that you can download and run Puppet. Again, it is free. So there is the enterprise that comes with a lot more features and that web-based interaction, GUI, graphical interaction. However, you can use it free without that. It's essentially all command line, which is not all that difficult to work with, just something that you need to spend a little bit of time with. There is also kind of this cheat sheet that goes over the core resource types that can be very helpful. Kind of download that and use that until you get completely familiar with them or remember them because you're using it so much. There is the Cisco Puppet User Guide. This actually, I don't believe this is actually in pre-release draft any longer. I think it's now actually public. So there is some internal documentation. That should actually be now made public. So do take a look for that, and I'll update the slide with that newer link so that the PDF of the slides has that link for you to download.